Hello everyone, this is Nick at Candlelight Observatory. Like many of you, I've been interested in astronomy for many years, and for the last year or so, I've been pursuing astrophotography. What I enjoy most about astrophotography is the challenge of getting the gear and the software to work together to be able to capture data on an object that can be processed into a final image. This is the first time I'll be documenting my image capture and processing of a deep sky object. I'm by no means an expert, however, I wanted to share my capture and processing workflow that may be of some help to someone else. Please feel free to use the comments below to offer criticism on how I can improve my own process. That would be greatly appreciated. I'll now show my capture and processing of M94 Cat's Eye Galaxy. Thanks for watching. Utilizing an ASI 1600 Pro on a 10-inch LX200, I'm capturing 75 frames for each LRGB filter. The exposure length for each is 60 seconds. This will give me a total of 5 hours of data. As you can see, in starry night, which I use for my observation planning, M94 is at a good altitude to start imaging by 9:30. I'm utilizing 60-second exposures in order to keep the ADU under 1000. This will ensure a good contrast between the object and the background and also controls the effect of light pollution. I decided to utilize the Rotate Through Events option in Sequence Generator Pro. This ensured that I would have data to process for each filter just in case clouds developed and cut the session short. In SG Pro's autofocus settings, I set it to run every 28 frames. Due to my astronomic filters being parfocal, it's not necessary to focus with each filter change, while SG Pro is rotating through the events. I was also very pleased with my auto-guiding. PhD2 was able to maintain an RMS error of approximately 0.7 arc seconds throughout the entire imaging session. So here we are in PixInsight. I have processed using the batch pre-processing script in PixInsight all of the LRGB data that we captured over the last couple of nights. You can notice there is some misalignment. That was due to the fact that these were captured in more than one session, and PixInsight did a really good job aligning those images, and we're going to be cropping that using the dynamic crop, so that won't even be a problem. First thing I like to do is I like to process my RGB first. So in order to make things easier, what I like to do is I like to just go in and rename the images here to R, G, and B. It just makes it easier later on to identify them. First thing I'll do is I'll bring up channel combination, and right here, R, G, and B, we'll bring those together. We'll unlink those channels. So the image has not yet been color corrected, so we'll unlink those, and we have the use the screen transfer function to see what we have going on. First thing I like to do is conduct a dynamic crop, which we'll do here. Okay, and we'll create an instance because I'm going to want that later on for to use on the luminance as well. So we'll process that, and there we go. Okay, one of the first things we're going to need to do now is a background extraction. And I'm going to use the automatic background extraction and see how that works. I'm going to subtract, and I don't care about the background model, and I'm going to just replace the target image and see what we end up with. So we're looking good so far. What we're going to do now is we're going to select the preview to get a nice piece of representative background. This looks like a good area right here. that up. There we go. It's going to be our representation of the background. Do a background neutralization. We'll select that preview. Done. And then we're going to do a color calibration utilizing the same preview. And we'll restretch. There we go. And we can get rid of that preview. Now, I want to denoise the background, but I do not want to take too much of the galaxy away. So we're going to create a range mask, which will have the stars and the galaxy protected. In order to do that, we have to create a clone, and I'm going to have to stretch that clone because range mask will only work on a non-linear image. I should probably open up the preview so I can see what's going on. And I kind of had an idea of where I was moving the midpoint anyway. So here we go. And I want to try to bring that black point in just a tad. There we go. And that looks good. And we'll apply that to the clone. Now we can go to the process, mask generation, and range selection. We'll start a preview here. What we're going to do is we're going to create a mask that encompasses as much of the galaxy as we can, while also eliminating some of the background noise as much as possible. So that looks good. And there's our range mask. We'll just keep the clone in case we need it later. So now we'll apply the range mask to the image, and we need to invert it so that we're protecting the galaxy and the stars, but we leave the background unprotected so that we can conduct our noise reduction on that. So using Control K, just going to unshow the mask. You can toggle that on and off, but the mask is certainly there. And I'm going to use my TGV denoise. And in the local support, what you want to do is you want to take that image's shadows and midtones and you want to populate those fields. So we can come down to the screen transfer function, click this little wrench down here, and this shows us the parameters. So there is our shadows. Here's our midtones. Using the keyboard shortcut Control C to copy and Control V to paste. And now we have those parameters in there. And the supporting image is this whole image. So now we'll run this and see how we end up. Now some folks like to run the denoise on the entire image without masking. I don't. I like to try to keep as much detail as I can so that later on when I combine with the luminance, I have that much more detail and stuff doesn't get muted out, so to speak. So there we go. We have a noise reduction done there. We'll take a look over here. Looks a little mottled now, but when right now it's stretched so much that's why it looks mottled. That's good. That won't even be noticeable later. But we'll give a little before and after. It's a pretty dramatic denoise. I'm also going to run the multi-scale linear transform on it, and I pre-populated what I like to use for most images the parameters, and we're going to apply that as well for some more denoise. And I will remove the mask, and I will do an SCNR and remove some of the green from this image as well. There we go. So now what we're looking to do is go nonlinear. I've done as much nonlinear noise reduction as I care, linear noise reduction that I care to do right now. So we're going to go into the nonlinear realm. And to do that, we're going to go into histogram transformation. Undo that. We'll open a preview. And we will now stretch that image. And that looks pretty good right there as our starting point. And I'll apply that. And then we can do some more work in curves. So I'll open up the preview there. And we'll do classic S curve to start. Get some contrast going. We will increase the luminance a little bit. We don't want to lose data too much in that core. We don't want to blow it out. Like if I put that up there, I blow out the core. I want to bring that core down a little bit. And then also I want to get a little color saturation going. I'll bring that up. That's looking nice. Right about there. And this is to taste. Right about there. And that's a really good starting point, I feel. And I will drag that. So there's our RGB. There's our before curves. And there's our after curves. Nice difference there. The other thing I like to do, we're going to just try it now. Sometimes I wait until I have the LRGB combined, but I'm going to see how local histogram equalization works out to bring out some detail in the galaxy itself. And we could be really conservative with this. So there's a before and an after. That's a pretty dramatic difference. So I'm going to turn the amount down to about 80. And there you go. You can see dramatic detail gets brought out in the RGB channel. So I'm really happy with that. We will apply that. So there we are with our RGB. And we will now start processing our luminance channel. So here we are with our luminance channel open, and the first thing we want to do is crop it the same geometry that we cropped the RGB. So we're going to open up that instance that we created. It automatically applies it there, and there we go. And I can close dynamic crop out. Next thing I want to do is run an automatic background extraction on this luminance image. And once again, we'll choose subtraction. I'll disregard the model and replace the target image and drag that on. And that's a really nice result there. Next thing we're going to do to the luminance is we want to run deconvolution on it. Now the three things that you need, the three types of images that you need is a star mask, a point spread function, and a range mask. And I'm going to create each one of those now. First one I'm going to do is the star mask. Go to mask generation, star mask. So I'm going to run this, and let's see how it turns out. And there is our star mask. And as you can see, it's the brightest stars in the image that are protected. So that's exactly what we're looking for. So we're going to put this over here. It's one of our support images. The next support image I need to create is the synthetic PSF, which utilizes the dynamic PSF process. Now, I've created an instance of a dynamic PSF process that I used earlier, where I selected 25 stars, and the key is to avoid overly saturated stars like this one. I like to have, if you look in the A column here, I like to have stars that are in the range of 0.01 to about 0.10. And that gives a good synthetic PSF when we create that. So I will select one, then I'm going to hit Control A to select them all. Hit this little camera icon here to export the synthetic PSF. And there we go. There is our synthetic PSF. So I can exit out of this session, and we'll put this second support image right here. The third support image that I'll create is a range mask, and we do that by using the range selection process. Now, we can't run that process on a linear image, so I need to create a clone of the luminance that I will stretch in order to work on with that range selection process. So I'll open up the histogram transformation process, and I will stretch that clone so we have an image that we can run the range selection process on. And I will apply that, and there's our stretched clone. I'll then take the range selection process, which I've created an instance of, and populated it with numbers that work for me for this particular image. And I will apply that. And as you can see, I've smoothed it out a bit in order to get some of those rough edges off. I like doing that. And then I'll apply that to that image. And there is our range mask, our third support image, which I'll place up here for now. And I can close out of the range selection process, and we no longer need this clone, so I'll close that as well. Now that I have the three support images, we can start the deconvolution process. Now, the first thing I want to do is take that range mask we just created, and I want to apply it to the luminance as a mask. So there's our mask, and the purpose of this is to protect the background. And I will hide that mask so we can see the image that we're working on. I'll now open up the deconvolution process, and under the PSF, we have the external PSF tab selected. I will select the PSF that I created, that synthetic PSF, that is now populated there. Under local de-ringing, I will select the star mask that I created earlier. And you will have to experiment on the global dark and the global bright to eliminate artifacts. These are the numbers that I found worked well with this particular image, and the iteration should be somewhere between 20 and 80. In this case, I went with 80, and this is going to take a while to run, so I'm going to execute this now on this image, and I'll be back once it completes. So now that this image has been deconvolved, the next step is to do some linear denoising. And to do that, I want to keep the mask in place, but I want to protect the stars in the galaxy. So I'm going to invert the mask and show you what that is. So now I'm protecting the stars in the galaxy. And what I want to run is TGV denoise. And once again, I want to take the parameters from the screen transfer function, do a copy, and in here a paste, and then the midtones, copy and paste, and I'll run that. And that'll just take a couple of seconds to run. So there we are. It's a great, that's the after, and that's the before. There's the after. It's a great job in removing the noise. I'll also run a multi-scale linear transform with my pre-populated parameters that I like to use, and that'll just take out some more of the noise that's left over. And there we go, that's finished. And the next step is to go non-linear with this image. So in order to go non-linear, first thing I want to do is remove the mask. And I'll open up the histogram transformation function and open a preview and stretch this image. And there we go. And I'll apply that. Now that both the luminance and the chrominance are non-linear, what I need to do is upscale the chrominance to the same geometry as the luminance. The chrominance, when I shot the RGB images, those were binned 2 by 2, and there was no binning done on the luminance. First, in order to make things easier, I'm going to rename my images, the identifiers. I have Lum for my luminance, and we'll go down here and change that to RGB. And then in order to upscale, we use the star alignment process. So in star alignment, I will select as the reference image the luminance, and then the target will be the RGB. And I will run that. And there is our upsampled RGB or chrominance. And as you can see, if I go to the process console, you can see right here that it was scaled 2.0. So it upsampled that image. The next thing I want to do is I want to run linear fit on the luminance in order to match the chrominance, the luminance channel that's within the chrominance now. So what I'll do is I will extract the luminance channel from the chrominance. So we have that there. I'll minimize this RGB. So I have the chrominance. I'm going to open up the linear fit process, and I'm going to select the RGB registered luminance as the reference image, open up my Lum, and apply that to the luminance. So now the luminance channel matches the brightness of the existing chrominance. So now that we have a luminance that is matched with the chrominance, it's time to combine them. And we do that using LRGB combination. So I'll open that process up, and I will select the luminance. And I want to make sure that RG and B are not selected, because I'm only going to be selecting the luminance. I'm going to open up my chrominance image, and I am going to drag that instance onto the chrominance, and it will combine both images. So there I go. And that is the after, and that's the before. After and before. And what you really notice is the stars get a lot tighter in the combined. So there's the before, and once again there's the after, because I deconvolved the luminance channel, so those stars are a lot tighter. The next step I like to perform is an HDR multi-scale transformation. So there's the default, always works pretty good. So I'm just going to apply the default, and what that's going to do is that'll reduce the blown out core of the galaxy. So there's the after. You can see the before and the after. Dramatic difference there. The next thing I will do is go into curves, and I want to bring out a little more color, and I want to reduce the brightness of the background just a little bit. So what I'll do is I'll drag that down to decrease the background, and we'll increase the contrast just a little bit. And then I also want to go into saturation, and I want to bring out the colors a little more. So once again, this is to taste. Everyone is different. I don't like my galaxies oversaturated like that. I like to kind of bring them somewhere in the middle. Right there looks really nice. Close the preview, and now I'll apply the curves. So now you can see the after. So here's the before, and then there's the after. We're getting a good result there. The last thing I like to do is run a local histogram transformation in order to bring out more detail in the galaxy itself. Now, in order to do that, what I'll do is I'll apply the mask that I created earlier, because I don't want that local histogram equalization to change the background. So I want to apply the mask, and as you can see, the mask red protects. So red is protecting the background. So when we apply this local histogram equalization, it will not affect the background. So let me open up a preview, and that looks really nice, but I want it to be more subtle, so I'm going to change the amount down to about 65. There's 65, and here is a before, and there's an after, and that's exactly what I'm looking for. So I'll close the preview, and I will apply that process to the image. So once again, there's the after, there's the before, and the after, and you can see that's a great reveal of the detail in the spiral of the galaxy. And the last thing I'll do is just take the mask, remove the mask, and I'm pretty much done processing this image in PixInsight. I could bring it into Photoshop and tweak the colors a little more, but for now it's just a matter of saving the image and posting it to Astrobin. Thanks for watching.